At the SQS instrument, we are studying really very fundamental processes. That means we are really looking to the smallest systems which are, let's say, producible in order to bring them together with the free electron laser light. That means really atoms, isolated atoms, and to see what happens when an intense FEL pulse hits an atom. What has happened then? How this reacts with the electronic cloud in the atom. And at the end, the electronic cloud in the molecule, this brings the bindings. I mean, you have to know what the matter or what is going on with the electrons in order to understand bindings in molecules, then understand bindings also in solids. So you have to know really on a very fundamental level the interaction of the matter with the intense FEL pulses. In order to do so, what we are doing, how we get this information, it's also different from most of the other instruments here. We are looking to electrons and ions. That means we are looking to the fragmentation of the little system of the molecule. We don't look to the diffraction pattern, how it can be done for larger particles and see what the structure is. We are using the electrons and the ions which are emitted after the interaction with the FEL beam and look to the direction in which they are emitted and look to the kinetic energy given to the fragments. And from this we can reconstruct the geometry of this little molecule at the very beginning of the interaction. This can be done then in a time-resolved way. That means we can define certain steps in the temporal evolution of a process where we measure for each individual step the kinetic energies of these fragments, and in this way reconstruct the initial geometry of the molecule for the different time steps. This allows us, for example, to see how the bonds on a molecule evolve in the time, how the molecule is really breaking up, when and how distances are changing, when angles are moving in a little bit more complicated molecule. But all this, in fact, at the end, I mean, we are really, let's say, on the fundamental level, we're doing experiments really to understand the fundamental processes on an atomic basis, the interaction with the light, with an atom. And this gives, of course, then a real fundamental and complete basis for all the experiments also which are done on a more complicated and more applied level. But this SQS instrument is really there, really to provide this basis on a very fundamental level.